Record. Okay. So once again, hopefully not too bad of a practice problem right there. All right. I think this is the only hour where I did get to grams and stuff. Is that right? So just real quick, will you tell your partner what the mass of lithium oxide would be? Like, this isn't a picket fence. This is just finding its mass. So how many grams are there in 1 mole of Li2O? There you go. 14 plus whatever 16 is. So 30. Everyone okay with how to determine that? Okay, we're going to use that over and over and over today, the ability to find the molar mass from something. If you didn't know how they did that, they looked in lithium and it was a 7 and a 3. They looked in oxygen and it was a 16 and an 8. And they took the big number and multiplied that by 2. And then they added just one of these big numbers. All right. So 30 grams of Li2O. All right. So we're comfortable with that. All right. Did we do this whole problem or did the bell ring? This is page number 11. We did that one. Okay. So just as a review, so we balanced it. We would have had a 2 here, a 1, 2, 1, 1 probably. That sound about right? Okay. Then the next thing we would do is take the unit and the number that was given to me. And I know you already have it, but we're just a review because it was a 3-day weekend. So the problem gave me 1.8 moles of HCl. Then I absolutely know that whatever unit is here always goes down here, right? So I know down here is moles HCl. Okay, then I don't really know what to do. Like some of you figured it out, but don't guess. Let's go backwards and figure it out. So it wants me to solve for the grams of H2S. Then using the periodic table, we would have found that there are 34 grams in every mole of hydrogen sulfide gas. So it would have been 34 grams H2S. Now, we know that the unit at the end is always the unit at the end. That's how I knew this went here. All right. There's something else you should commit to memory, and I'm sure I said it a while ago, but anytime we find the grams, it's always per 1 mole of the same substance. All right, grams will always match per 1 mole. Now, the 1 mole could be on top and the grams on the bottom. That's allowed. But we know whatever we find the number on the periodic table, it is grams per mole. All right, then finally, that will tell me what goes up here because the unit up there always matches the unit here, right? So now I know this is mole H2S. Fair enough? All right, these values I find up here. So H2S had a 1 in front of it. And then HCl had a 2 in front of it. So I'm just going to put the 2 and the 1, and then I'm ready to go. 1.8 times 34 divided by 2. And this was 30 point something. Is that right? 30.6. Okay. Now I know that was all review, but let's now turn to page 14 or 15 now, I don't know, and just work on homework practice problems. So right there, page 14. Now, will you all take a time out just for a second and look at the screen? This is where kids sometimes get confused. We're not going to change anything about the process, but you want it to match this model every time, but it doesn't. This question gave you moles and asked for what answer? Grams, right? Okay, look at number 40 in your homework. It gives you grams and asks for moles. So it actually is this way. Now we don't set it up backwards. We just set it up because we know the process is I take the number and unit given. I put the unit here and here. I know grams is going to be per mole, which tells me here and here. And then I find the unit of my answer. Okay. Don't memorize like the structure of it. Memorize the process of doing it. Okay. So here we go. If we have 35 grams of magnesium and it combines with oxygen in a composition reaction, how many moles of magnesium oxide will be formed? Okay, so first step always is to balance it. This one's a very common one, a 2, a 1, and a 2. Okay, why don't you, now remember, don't try and make it match exactly the previous one. Follow the process. See if you can do that on your own for the next 2 minutes. All right. Who's still working on it? Actually, I see a ton of you working on it, so keep going. All right, let's do it because I see something that definitely will make you do something wrong. I see like 5 or 6 of you looking back at the previous problem, trying to do it the same way. It's not the same way. So that's why I say follow the process. Don't memorize the order, follow the process. So the number and unit I give you goes here, 35 grams of mg. The process says that this unit here is always the same as this unit here. Now, before it was moles, which was fine because the previous problem, the number and unit I gave you was moles. This is grams, which means down there has to be what? Tell your partner. Grams of mg. Then we'll have to reinforce this with over and over and over. But anytime you have grams in your picket fence, tell your partner it's always per what? 1 mole of what? The exact same thing. Your gram and mole ratio never switches the chemical. So we know that the top here is 1 mole of mg. Now I see a lot of smart people erasing. This commonly, if you screw up, you put a 2 right here. Is that what you did, Jensen? Nope, that's what you did. Don't put a 2. The 2 makes sense because you're like, hey, there was 2 here. I know that seems to make sense, but it's in the wrong spot. Okay, so we find this number on the periodic table. Magnesium is a 24 gram per 1 mole substance. You okay with that? All right, then next, let's go yellow. This unit here, tell your partner where it has to go. It has to go down and over, right? So we know that this is mole of Mg. Then this one I know, and maybe you know, but let's just double check. What do I want to answer, or in my answer? I want moles of MgO. And the unit at the end, my friends, is always the unit at the end. All right, so what do I have in front of MgO? I have this 2. In front of Mg, I also had a 2. Now, you might look at this step and think, well, that's pointless. And you know what? Math-wise, in this particular problem, that was pointless. But it's not always the same number over the same number at the end. That was just how this one worked out. So follow the process, because this could be a 4 and an 8, or that was whatever. It could be whatever we find from here. Okay, math-wise, I take 35. I'm just going to reduce this to 1 over 1. So I just take 35 and divide it by 24 and get 1 point what? 46. Are we all right with that? Is that not what you got, Zito? You're good? This number, that's from the periodic table. Whoops. Ooh, it's struggling. When you look at Mg, like I can see that one. There's a 12 and a 24.3. Now on your periodic table, it's reversed and it's just a 12 and a 24, but it's the big number in the box. So it's just magnesium. So I go to the periodic table, find the symbol for magnesium, and take the bigger value. Go ahead.
I did it a different way and I got the same answer. Like the only way to do it was
What did you do?
so I got the green.
Okay.
And then I started from the back and worked back. So I had like grams of
MgO.
yeah, over grams of Mg, and then the second one was like the top was still moles of MgO, but the bottom was still.
So that worked out okay, probably because these were the same number.
Okay.
If they weren't, you would have missed that step and then you've been wrong. And we're going to go grams to grams today. And most kids like gram to gram because it's the same every single time. And what you did is you went gram to a gram on accident. So, all right, let's look at number 41. Hey, there's the answer, but now it's gone. Lithium, ooh, that's out there. Lithium reacts with water in a single replacement reaction. How many moles of hydrogen gas can be produced by 10 grams of lithium? Did I read all that right? Let's fall on that screen. Okay, so the first step is to always balance the reaction, which that'll be a struggle for a lot of you. So I'll help you. LiOH plus H2. If I let you do this on your own, you forget that too sometimes. I probably said this Friday, but any of the math ones on the exam, the chemistry will be done for you. So you won't have to balance and do math. There'll be test questions where you just balance, and then there'll be questions where you just do math. Sorry, there's no space. That was unintended. You done? Oh. All right, how was the SUU party? Good. More fun than ice skating? Who had fun ice skating? Whose ankles still hurt from ice skating? Okay. My left ankle's like just shredded, like not hurt. The skin is just gone on my, I should take Bert's class, but the curvy part of your ankle bone, yes. No, that was Carly's first day ever. Yeah, we have rollerblades at home, so we skate there. But my rollerblades from 1991 that I spent $390 on finally broke last summer. Like the plastic, I was putting on the thing and tightening it, and it just like, bing! And my childhood died at that moment. That's when it ended. All right, this was common too. 2, 2, 2, 1. Anytime you have a family 1 reacting with water, it's always this 2, 2, 2, 1. All right, now I'm going to follow the process. Here we go. We will have 10 grams of Li. All right, which means down here I have grams of Li. Tell your partner where you found that number and what the number is. It's 7. Who had 7? What'd you have, Shelby? Do you know how to find it? Lilia, train your BFF. So you open the periodic table, you find Li, and you see it is 7 grams. Now, anytime I have grams, it is always tied to who? 1 mole of the same substance. Your gram unit, which is Li, and your mole unit will always match, which is Li. Which means what unit must come down here? Mole of Li. All right. Now I get stuck, so I need to know what I'm solving for. How many moles of H2 is what it wants in my answer. So I know that the unit at the end is the unit at the end. So this is moles H2. So then I put them in. I have a 1 in front of H2. I have a 2 in front of Li, and I'm ready to roll. So I basically have 10 times 1 times 1 divided by 7 times 2. So I have 10/14, which is 0.71 or something like that, isn't it? Okay, from the very start, who had 0.71? Raise your hands. Okay. Didn't go super swimmingly. What do you have? Did you make a mistake? What did you do wrong? Got you. All right, that's super common. Bobby said he just put the mole of H2 right here, right? Okay, don't end it short. Now there is a way to know. I'll usually talk about this early, but there's a way to know how long the picket fence should be. Oh, I forgot about my Bernie Sanders. That's just entertaining. Hey, just real quick, I usually show this way later, but look in the middle of your periodic table, in the bottom middle-ish, and you will see this helpful thing right here. So open up right here. Everyone look at it. Everyone look right here. Okay. This is how you'll always know how long it should be. And this will help a few of you. First off, will you put a line straight through the center to divide it into two parts. I gotta have this bigger somewhere. There we go. I taught this like the day after the inauguration in whatever year this was. And this just picture went crazy. And so I thought it was hilarious. I just put it on my slides. I know, I'm 12. Okay, this thing, this I call the map. There's a song about that as well from Dora, the Explorer. It's called the map. Okay, and like I said, I usually don't use this for a while, but we can look at it right now. This map tells you how to do everything we've been doing. And you'll notice we first started where we were given moles, and then we were asked for moles. That's what we did Friday. And that shape of that picket fence, it was a horizontal line and one vertical line, right? So to go from moles to moles, I just had this structure. But now I'm going from either, I'm looking for that button. Thanks, Tom. I'm going from grams to moles, or I'm going from moles to grams. And on this map, if we go grams to moles, we're going to go 1. We have to come across this line. We always have to go from the given side to the unknown. So we take 1, 2 steps to go from grams to moles of what I want. Sort of with me? All right, that structure would have 2 vertical lines. Looking here, if I am given moles and I want grams of something else, that takes 1, 2 steps, or the structure of the periodic table would have 2 vertical lines. Each arrow or step represents one of the vertical lines you would put. Okay, so coming up in about 10 minutes, we're going to go from grams to grams. And that would require 1, 2, 3 steps, or it will require a picket fence with 3 vertical lines. You all right with that? This map really does help you figure out how many steps, and once you know the steps, you know where you are, you know where you want to go. It all comes together pretty easy. Okay, now while I've been saying all that, maybe some of you already moved on. I have every answer already written. Let me just clean this up. All right, here we go. Are we on 42? Okay, 42. Let's do it. I'll help you with the chemistry because it's hard. Now, 42 is different. What's different about 42? You're right, all of you. You're all 100% right. This time it gives you moles and asks for grams. So will it match the exact same thing you just did? No. Follow the process. Okay, try it on your own for a minute. All right, let's work through it together. The hardest part of this might be finding the mass. So it gives me 3.5 moles of sodium sulfate. Okay, I'm going to teach you guys something I do all the time. You're welcome to do it unless you are confused by what I'm about to do. If what I'm about to do confuses you, then don't do it. But I'm going to have to write these formulas a lot, right? And I don't want to do that. So this is what I would do to save you some time. And my AP kids, I make them do it to save time. I'm going to call this A, B, C, and D. You all right with that? And it's just to save me some writing. You'll see what I mean. So it gives me 3.5 moles of sodium sulfate. So instead of writing Na2SO4 3 times, I'm just going to say 3.5 moles of B. That makes sense? Okay, then I know what unit goes down there. Moles of Na2SO4, which I am just calling B to save me some time. Fair enough? Okay, now this is where I'm stuck. I don't know exactly what goes here, and I don't want to guess. I want something to tell me what goes there. So I'm going to go to the end, and it wants how many grams of barium chloride. So I'm solving for grams, and I'm just going to stick with barium chloride being A. You okay with that? So grams of A. Now, anytime I write A, it's representing barium chloride. I'm not just magically changing stuff. So the unit here always matches the unit here, grams of A. And anytime I write grams, it's per what? 1 mole of the same thing, which is barium chloride, but I'm just referring to it as A. Okay, that means what comes up here? What unit? Moles of A. Then I just fill stuff in. I look for the coefficient in front of B, and that's a 1. I look for the coefficient in front of A, and that was a 1. And the only other thing I need is the mass of barium chloride, which is that 197 or is that a different problem? 208, okay. So it's just 3.5 times 208. And I don't know, what did you get, Zito? 728? Raise your hands if you got 728. All right, Gary, you're my best friend. What went wrong? You got a really small number? Let's see what we got here. All right, you put the mass here. So you didn't need to add Na2SO4 up ever in this problem. And I know why you did, because the last time the grams went here, right? But this one, it's reversed. So tricky. Anybody else that I can look? A lot of people didn't raise their hands. You know what you did wrong? Right here. Okay. Yep, don't. Right here. All right. So BaCl2 to find the mass. This is your problem. This has been closed the whole day. Oh, you were? Okay. So you have barium, 137, 35.5, but you double that one because it's BaCl2. So what was barium again? 137 plus 2 times 35.5. And that would give you that number. Got you. Okay. We all right with that so far? All right. Well, then the next step we're going to do is grams to grams. This one looks like this. Now, it might be more intimidating, but we're just following the process. You just have to find the mass twice. So here we, no, here we go. Nope. That's not what I want. Okay, go to probably page 10, 11-ish, whatever we're on now. All right, this is the top of page 11. How did it go? Did it work?
I don't know. I haven't checked it up.
All right. This is the one you'll be tested on the most, is grams to grams. It's the most common way it's actually used in the real world. We have a certain amount of grams of something, and we want to know how many grams of something else we can make. It's not too bad. Like, it would be like, you have 100 grams of chocolate chips, how many grams of cookies? Now, we don't cook that way. We talk about like cups and amount of cookies, but it would be similar. All right. We will just follow the process, and it's not going to be awful, I hope. 79 grams of aluminum oxide. So I start with 79 grams of Al2O3. I don't know. I can look. It's set up right, but the mass of Al2O3 isn't that number. That's Al and O, but you got to do the 2 and the 3. All right, then I'm going to just color code, because why not? I got a cute highlighter pen right here. And hopefully all of you could do this. If I asked you, you would just know these things always match. Right? Those units will always be the same. So down here, my friends, what unit comes down here? Grams of Al2O3. That's not impossible. All right. Now, tell your partner, grams are always tied to what? All right, 1 mole of the exact same thing. We got to be specific, because if I am very specific on my units, then I really am very clear on what's next. So what's on the bottom of this one? Whatever that unit is, right? Mole Al2O3. Okay, now this is where I say I'm stuck. I don't know what goes here, even though half of you probably do now, but maybe you don't. So when you're stuck, you work backwards. So go to the end. What is it asking me for? Grams of Al, right? Which means what goes here? Grams of Al. And grams is always tied to what? 1 mole of the exact same substance. And then this unit must go where? Up there. Okay, now I'm ready to fill in all the numbers. So aluminum is what, Kellen? Top right-ish. Well, more in the middle. It's by the fold. Never mind, it's right there. Oh. It's 27 grams for every 1 mole. Okay, now, where do these numbers come from? Tell your partner, where do the mole and mole numbers come from? The balanced equation. So there's a 4 in front of aluminum, and there is a 2 in front of Al2O3. Okay, then the last part, and probably the hardest part, is right there. The Al2O3. Is that 127? No, 102. I'm way off today. 102? Shelby, do you need help on how we got that number? What did you get? 73? I don't think it's 73. Well, yeah, the answer first. We're just looking at this right now. So Shelby and anyone else, Al2O3, you had 2 times 27. because that's what aluminum is, plus 3 times oxygen, which is 16. Yeah, don't add. How dare you? All right, then we're ready to just do the math. To save some time, I would reduce 4/2 to just 2/1. So 79 times 2 times 27 divided by 102. And Zito, you said 40 point something? 41.83? 82? Okay, sorry, I gave you such attitude right there. 41.82. Fair enough? Fair enough? Oh, no. Is that a 7? Yeah, that is. Just a type error somewhere because everything's set up right. Okay. You multiply. Nope. Oh, is that a 22.4? It's a 22.4. And then you're solid, my man. Good job. Okay, homework time. Oh, never mind. I forgot. Before we go to the homework, I want you to do one more practice one. Do on the bottom of page 10. Did we already do something on the bottom of page 10? Page 10 or page 11, there's room at the bottom. Well, no, you got to do that. Yeah, bottom of page 10, do this one. I'll help you balance 2, 6, 8, and 10, or 1, 5, 3, 4, whichever one you like. It's not anywhere, Shelby, you're just writing it down. So in that little space on the bottom of page 10, or anywhere you have space, you can do this problem. So this is a gram to gram. How many grams of oxygen and 580 grams of C3H8. Okay, see if you can do that one. At Bonneville today, is that right? And home swim meet. We got wrestling this week, Gary. Home or away? Got you. One of your friends has been emailing me to raise his grade from a 0% to a D-. Who would have a 0 in this class? No one in this class with great hair and a beautiful smile. Oh, never mind. Someday though, David, right? You'll come in and do all that work. Oh, sweet. Zito, you like the letters, huh? It's nice. It's all I do in AP. Like after the first 2 days, like I'm never writing a formula again. I'll be honest on this one. Lots of people get this number wrong right here. Do you know why they get that wrong? I didn't look at yours, don't panic. They forget it's diatomic. So don't put a 16 here. 16 times 2, that's a 32. All right, time-wise, I gotta go. So here we are. I mean, go pretty quick. Once this process is clicked, it's not bad. We have grams of C3H8 on the bottom. Anyone have that already for me? It's 44, right? Grams is always per 1 mole of the same thing. Whatever unit is here has to go down there. C3H8. Then I don't know, so I come back to the end. Grams of O2, grams of O2. That is 16 times 2. So that's 32 grams. Grams is always per 1 mole of the same thing. Then whatever's here goes there. So I have, whoops, I never wrote mole, sorry. Mole of O2. From my reaction, I have 10 O2. I'm going to reduce this to 1 and 5. You all right with that? So I have a 5 in front of O2. If you put a 10, don't erase because your calculator took care of it anyway. And a 1 C3H8. And then I'm ready to go. 580 times 5 times 32. That's a big number. Then I'm going to divide all of that by 44. And I end up with 2109. 2109. All in favor? Front row. 2109 grams of oxygen. Okay, and that is how we go from a gram to a gram. The bell's going to ring in a minute, so don't worry. We will do some practice problems on that and probably a quiz tomorrow just to see who really is getting it and who's waiting for me to write all the answers on the screen. Yes, Diego. Okay, let me end this real fast.